Hello and welcome back to Universe Sandbox 2, but before we start, just a reminder, today is Mother's Day, so if you have the time, which you definitely do, go to your mom and just tell them thank you for being a great mother, or, you know, just be nice and do something special, because parents have a pretty hard time, well, depending on how, well, challenging you are as a child. Now that that's done, let's begin. So, we are today going to be testing if rotational forces in, Universe Sandbox 2 actually affect the outcome of impact, which they certainly do, but we're going to have a control anyways. So our control is just going to be two words, and we're just going to have them 100,000 kilometers away from each other, and just a normal collision. So let's see the result of this. So we're going to see Earth does have a rotational period of 24 hours, believe it or not. So it is rotating, but not enough that this will actually mess up our control. And as we can see, they both kind of merge and throw out a bunch of particles. One survives and continues on its way. So that is our control for the experiment. Now we're actually going to try upping the rotational period. But in order for this to work, we have to up it by quite a bit. We're going to start by putting down two words. We're going to have one spinning at normal speed, and we're going to be spinning one at one spin per second, or one rotation per second, which is 60 RPM. And as we can see now, that Earth is spinning extremely quickly, so fast that it actually can't really be seen spinning if we speed things up too fast. Let's get back into our nice viewing mode, and let's see the effect of having the Earth spinning this quickly. So you can already see it's spinning its atmosphere away. It's actually throwing it off. There's little bits coming off. And it's actually causing this Earth to spin in the direction you wouldn't think it would spin in. It's being pushed in the wrong direction. But let's continue. Because of it making it spin, it's able to hit every single side of this Earth by rolling it, and it's actually causing streaks to appear across the planet. Kind of like when you fall off your bike and skin your knee. There's just giant streaks going all the way down Earth. That example. And this Earth is actually being hit pretty hard too. Every part of this Earth has been hit, except for the top, which isn't rolling, and I'm assuming the South Pole is pretty similar. Yeah, there's a little bit on the bottom that aren't hitting either. Okay, so let's continue watching this, and wow, this is taking a long time. And there's a lot of damage being done even before they get close to each other. This one's being sped up so fast, they're now just ripping each other apart, causing a huge amount of debris, much more than last time. And we're done. The resulting Earth is spinning extremely fast. But is it going as fast? Let's see. If we click on Earth and we go to its rotational period, it's about doubled, but it's still very, very fast. So, now let's test two words, both spinning extremely quickly. So we're going to go on each one. We're going to set the rotational period to 1 second. 1 second, and let's quickly press tab, TL, And we are ready to begin the experiment. So both Earths are spinning very fast. When they hit, are they just going to cancel each other out? Maybe. Maybe not. Oh, you know what? It looks like they are. No, maybe not. I don't know what's going on. It would be funny if they just stopped because of canceling each other out. No, we're seeing the same effect as before, just a little bit more so, with thousands of craters appearing all over each Earth. Tons of material being thrown out, and in the end, it kind of looks like the Earth has chickenpox. And boom! What an explosion. So yeah, spinning definitely does impact the explosions in this game. And we're going to try this with a crazy experiment, I guess. We're just going to do a smaller planet than Earth, Mercury, but we're going to have Mercury spinning very, very, very fast. And by very fast, I mean we're going to go to its rotational period, and we're going to turn it to 0.001 seconds. Now it's spinning so fast that we actually cannot see the spin. But will this be enough to I mean, it's normally enough to absolutely annihilate the Earth. But will it, like, rip the Earth completely apart? What will happen? After this, we'll try an even smaller object spinning very quickly. I know we don't have any control for this, but we pretty much know what's going to happen normally. It'll just kind of absorb Mercury. Here it goes. So, even right in our speed, this is spinning at thousands of times every second we're looking at it. Actually, about 4,000 times per second. So you have to imagine it's spinning that fast. It is actually speeding Earth's rotation up a lot. The rotational period of Earth is now almost at 1 second. Yep, it's about to reach that. Jeez. Look at the damage. It's leaving a huge streak all the way across Earth. This is actually quite interesting. Let's quickly take that for a thumbnail and continue. Earth is just being pwned right now, even by something so much smaller than itself. It's being ripped completely. Well, I want to say ripped apart, but there's a huge, huge cut through the equator. And any second now, we're going to see this die down as Mercury is finally... Whoa! It's thrown out two really, really large chunks that are bigger than the moon, which are then going to re-collide with Earth. And it looks like that is a good way to do a lot of damage to a planet. The rotation definitely makes everything more deadly. So speeding things up, we can see that, yeah, Earth is not doing well. Not well at all, especially because its rotational period is just so stupid right now. Just melt the ice. Hey, look, it's Earth, except spinning super fast, and parts of several major continents are missing. Australia, no! I think the United States was hit hardest, though. It looks like the East Coast is still kind of alive. Africa has a few holes. Asia and Europe are doing pretty much fine. Australia has gotten larger. And let's try our last test. We're going to put Earth up against something that normally wouldn't do any damage. We're going to put it up against, let's do Halley's Comet. So let's do our control here so we know just how much damage Halley's Comet will normally do. We will follow it down onto the surface of the Earth, and we're going to collide in 3, 2, 1. Initiating collision sequence. And it is a hit directly in the Pacific Ocean. We see a pretty large shockwave from this, but not very much damage, honestly. We've made a new continent pretty much, but other than that, the Earth's temperature hasn't even been really affected, and it's not going to be that much of a problem. I mean, don't get me wrong, that is a lot of damage, but it's not the end of the world per se. So we're going to do this again. We're going to plop that down, but Halley's Comet is going to be rotating. And because of its extremely small, we're going to make it rotate extremely fast. So fast that I don't even know, that's less than a picosecond, so, you know, I don't know. I don't know what the word is for that speed, but it is spinning. And let's get our collision. Will it be able to roll the Earth? Such a small comet. It'll only be connecting with the Earth for a few seconds before it's absorbed, so it doesn't have much time to do its damage. Can we spin the Earth to death? Here it goes, and we're about to have contact with the Earth. Now I'm slowing this down a lot so that we can see that very small amount of time that it's actually touching the Earth's surface. And we were very close. Very close. Here we go. We have collision. This is it. This is the moment. Okay, first off, we can see the shockwave it's making. Is the Earth speeding up? That's the question. Okay, so the Earth's rotational period is amazingly being affected by this. It's even at this extremely small amount of time. 10 hours, 9 hours, 8 hours, 7 hours, 6 hours. It may actually go slow enough that this does a ton more damage. It looks like it only got it down to 6 hours. But for such a small object, that's a very impressive. And because of the rotation, it actually lets each of the particles get out a bit further and hit new spots, doing more damage overall. But yeah, that is definitely a bigger crater, but it's not super impressive. So we're going to do this again, but just bring it to the extreme. Technically, there's no limit to how fast we can go, so we're just going to add enough zeros that it seems overboard, like really overboard. So seconds. I don't want to crash the game, but there we go. It may not rotate at all now because of rounding, but you know, who cares about floating point errors? Okay, here we are. Halley's Comet moving so quickly that I'm surprised the game isn't dying at the moment. When it hits the Earth is going to react violently. So we're currently at 23.9 hours, and here comes the collision. It looks like we're going to be hitting right below North America, I think. I think that's what it looked like. I don't want to miss the explosion, though. And any second now. Slow, 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 slow. The Earth's velocity. Yeah, that's correct. Okay, the Earth's rotational period has actually slowed down to a fraction of a second. So we have successfully done it. The Earth is rotating so quickly that we can't even see the rotation. But what does this mean? Does this mean that we're going to see random parts of the Earth be affected by this, or is the simulation not even going to calculate that because it's too fast? Well, it looks like we have a much larger, actually I can't be sure about that. It looks like the crater and stuff are pretty much the same, it's just the Earth is now spinning extremely fast. Huh. Okay guys, thank you for watching this video, and I once again make sure you let your mom know she's appreciated because it is Mother's Day, and I will see you all next time. Don't forget to leave a like and subscribe if you enjoyed this video, and in the comments just say, did you expect that to happen, or was that a completely disappointing? Maybe we'll do more testing in the future. But, see you all next time. Don't forget to like and subscribe. And remember, it's Mother's Day.